Hi, I'm Charles Crouchman, and I'm the Chief Technology Officer at Turbonomic. I'm here today to talk to you a little bit more about application resource management, what it is, what's the problem that it solves, and at a high level, how does it solve that problem? So, as you've probably heard through other sessions, application resource management is really the problem of assuring the performance of applications by making sure that they continually in real time get all the resources they need to perform. And when you do that through the right sort of analytics and automation, you can lower your cost of infrastructure through the elimination of over provisioning. And like all automation, if you're going to take automated actions in the environment, you must ensure that those actions and the applications that they're automating are subject to and inherent to any business compliance rules that you have in place. So again, the goal of application resource management: improve performance of your applications while actually lowering the cost of infrastructure, all while maintaining compliance. So how does that happen? Well, if you look at a typical application on the left, if you've seen the Turbonomic interface at all, this is familiar to you. This is what we call the supply chain, but this is basically our full stack view of an application, all the way from the business application through the application tier, through the virtual infrastructure tier, through the physical infrastructure tier, compute, network, storage, on-premise, public cloud, containers, virtualized environments, whatever you have. So a typical business application spans many of these tiers. It can be partly on-premise, partly on the cloud. It could be partly containerized. It could have a database on the back end. The typical application stack is a very complex thing. And so the problem here is when that application is receiving demand, it's having transactions hit it through whatever mechanism it uses to take in transactions. That demand is always changing, both in terms of volume. Sometimes the thing is very busy, sometimes it's not, but also in terms of variety. So today, a particular sort of transaction, a sell transaction, might be very heavy, and tomorrow a buy transaction might be very heavy, or those variations can happen even more frequently. And that changing of demand drives a different demand pattern on that application stack. So at one moment, it might be the fact that you've got I/O congestion on a database causing a performance issue, but at the very next moment, that bottleneck may have moved to memory congestion inside of a JVM on the application server servicing the application. The demand, as it changes the place where congestion or resource contention can hurt the performance of the application throughout that application stack. So how do I solve that problem? How do I make sure that my application performs at all tiers, even when demand is changing, right? Whether the app is busy or not busy, or when the demand changes from one type of pattern that might be I/O heavy to another type of pattern that might be compute heavy. How do I make sure that the application continually performs? Well, the state of the art today, pre-Turbonomic, is to rely on over provisioning. So what people tend to do is they do their best guess at how much infrastructure resource each of those tiers is required, and then they kind of add 30%. So I'm going to add a fudge factor to say if there's unpredictable demand, I can absorb that unpredictable demand without having congestion and a performance impact. And that leads to two problems. The first problem it leads to, the first and most obvious problem it leads to, is over provisioning. Right? So what we've done is we've provisioned statically to a historical peak plus 30%, which means at any point in time, I've got somewhere between 30 and 50, sometimes as much as 70% more infrastructure than I need to meet my current demand. I'm not very elastic. The second problem it leads to, believe it or not, is performance problems. Because even though I over provisioned, remember the place I started from was a guess. I don't know how much memory that JVM needs to service the application, but I'm going to take a guess and then I'm going to add 30%. And if my guess was wrong, even if I added 30% on top, I still don't have enough and I'm going to have a performance problem. So the conundrum in the industry is that I have both an over provisioning and an underperforming problem at the same time. So that's the problem that Turbonomic set out to solve. And the way that we solve it is through a unified control platform. So again, the first thing that we do is you give us credentials into your environment, whether that's on-prem or the public cloud, at the virtualization tier, at the physical tier, at the application tier, and we'll discover everything that you have completely agentlessly, again, through remote APIs. So you see on the far left of this chart that we're starting to build out a tree or a graph of your application, that full stack view that we discussed on the previous slide. Then we understand not just what you have, but what the relationships are between them. So this is what we call stitching. So we build a view of all those individual components into a real application stack through our understanding of how these things relate to each other through resources in particular. The next thing that we do is we understand how resources are consumed in this graph, right? So we understand, for example, that a JVM uses heap to consume virtual memory from a VM, which in turn consumes physical memory from an underlying host, or potentially from a public cloud compute instance, for example. And so we understand how all the resources flow through that graph. Over 100 resources: compute, network, storage, private cloud, public cloud. And we arrive at that picture in the middle where we understand the full stack of the application and how that application consumes resources. Now, what happens next is where the magic happens in Turbonomic, which is what we call the analytics phase. We use market-based analytics, so highly patented analytics based on 30 years of PhD level research to model that graph as a marketplace of buyers and sellers of resources. And without going into how the analytics work, effectively what comes out the other end is a set of decisions. And these decisions are the decisions that are required to make that application perform. So based on current demand and an understanding of historical demand, how do I continually alter the configuration of that application, whether it's at the app tier, the virtual tier, the physical tier, the cloud tier, to make sure that that application is getting all the resources it needs. So it could be a scale decision. I may need to scale something up, make it bigger, or scale something down, make it smaller. It might be a placement decision. The place where it's running doesn't have enough resources, so we should move it somewhere that does have the right amount of resources. It could be a configuration decision, so changing the configuration of something so that it doesn't have a hard limit on the resources available to it, raising it or lowering it. Could be a start. We might need more instances of this thing, or a stop. We should turn this thing off. It's not being used and consuming infrastructure resources even though it's idle. And then there are specialized things for the cloud, like purchasing of reservations. And all those recommendations are produced by this analytics engine. And those are all, remember, Turbonomic is focused first on performance. Those are all performance-safe recommendations. Their goal is to make sure that the application gets enough resources to perform. And as a result of that, you don't have to over-provision. You get the infrastructure savings because you have a system feeding the resources, the right amount of resources to the application at the right time. Now, it's incredibly important that those recommended actions are accurate. The first law of automation is do no harm, do not break the application. So they must all be performance enhancing or minimally performance safe. So we may take an efficiency action to give some resources to somebody else, but that action must be performance safe. It cannot adversely impact the application that we're automating. And then finally on the back end is automation. These recommendations are great, but if all you do is hand them to humans, they'll probably lie fallow. They will not be taken advantage of. You won't get the value from the software. Partly because some of these actions have to be taken at computer speed, not human speed. But even the actions that can be taken at human speed, humans just are not set up to take these actions continuously. So it's best if you automate them. So on the back end, we have an automation engine, both native automation as well as the ability to drive external orchestrators to take these actions continuously in real time. And again, the result is I've taken these actions on this application, on these entities. I get better performance because I've eliminated resource contention and starvation. I get it at a lower cost of infrastructure because I've eliminated the need to over-provision. And I've done it all while maintaining compliance, because also built into this system is a full policy engine where you can define your policies and your compliance policies. So at its core, that's really how Turbonomic works. This is how it looks in a typical user interface. It's incredibly important as you look at these sorts of solutions that they are application aware. So I showed you that whole supply chain. I talked about the application stack. It's incredibly important that you bring together the infrastructure and the application because you want a couple of things. The first thing is you have to make sure that the resource configuration decisions you're making at the infrastructure layer are application safe. And to do that, you must be aware of the application. But also, if you want to drive your organization to take these actions, you must prove that they're application safe, performance safe. You must prove that they're beneficial. So you want to tie the fact that I'm resizing a VM to the fact that not just have I never used as much memory as I've got allocated to this thing, but also I can show before and after right in the single product the fact that after I took that action to reclaim memory from that VM to give to someone else, it did not have an adverse impact on the business application metrics like transaction throughput or response time. So I can prove that the actions worked. They did not adversely impact the application. So you must tie the infrastructure to the application so you get the right recommendations and you can prove that those recommendations had the benefit, drove the benefit that you promised, and did not have an adverse impact on the application. Right? And then finally, as you look at the full stack, what's important is that this works on the full stack. You cannot make a localized decision on a VM or a compute instance type. You must look up the stack at the application that's running on that compute instance or VM, and you must look down the stack at what it is running on to understand the constraints on how you can configure that thing. And so you must have a solution that it makes not a localized decision, but a system-wide understanding with localized decisions. And so you must have a full stack like you see on this slide here, all the way from the infrastructure tier, whether it's physical, virtual, or public cloud, through the management tier, through the traditional middleware tier, or the PaaS layer in the cloud, all the way up to the application. It must be full stack understanding with localized decisions, or you can break the app, which is the death of automation. All right, so that's my overview for today. Just a quick overview on the problem that we solve, application resource management, why it matters, better application performance, lower infrastructure cost, maintaining of compliance, how we do it, right? Abstraction, analytics, automation, why these things have to be application aware, applications and infrastructure connected, and why it must be full stack awareness, localized decisions. All right, thank you everyone for listening. I hope you enjoy the rest of Turbo Live.